Today we're going to work on evaluating trig functions using the unit circle. So I've got the unit circle in front of me. Hopefully I'm starting to memorize this, in particular the first quadrant, and being able to use the first quadrant to determine the points of intersection in the second, third, and fourth quadrants, whether the angle be in degrees or in radians. Let's first use our calculator though. If I were asked a question like evaluate the cosine of 30 degrees, I could go to my calculator, I could make sure that my calculator was in degree mode, and I could type in the cosine of 30. So cosine of 30 degrees, I need to verify what mode I am. I'm in degree mode, I'm highlighted there. So I can evaluate the cosine of 30 and I get 0.866. Now that's a rounded decimal, so this would be approximately 0.866. This would not be an exact value. If I wanted to do a problem in radians, I could find the tangent of pi over 3 in my calculator. I could change my mode. Now I'm in radian mode, so highlight that. And I wanted to do the tangent of pi divided by 3. Close my parentheses. I get 1.732. Again, this is a rounded approximate decimal. 1.732. What we're going to use now is the unit circle to find the exact values. So my primary trig functions will be the sine of theta, the cosine of theta, and the tangent of theta. We're going to come back to the fact that we generated this unit circle by putting triangles inside of our unit circle. These triangles had a radius of 1 or a hypotenuse of 1. The angle here to be 30 degrees or whatever measure I was talking about. We used 30, 60, 90 to evaluate the y value as 1/2 and the x value was the square root of 3 over 2. So sine, which typically for us from SOHCAHTOA means opposite over hypotenuse, if I look at that green triangle inside of the unit circle, the opposite corresponds with 1/2 or the y value, and the hypotenuse is 1, so I'm just going to get the y value there. The cosine, which is typically adjacent over hypotenuse, well, the adjacent corresponds with the x value. The hypotenuse is 1, so the cosine of theta will be associated with x. The tangent is opposite over adjacent, the opposite being the y value, the adjacent being the x value. The corresponding reciprocals, cosecant of theta, will instead of being y, will be 1 over y, or hypotenuse over opposite. The secant of theta will be 1 over x, or 1 over the cosine of that value. The cotangent will be x over y. So now we're going to begin to evaluate some of these trig functions. The directions here will be to evaluate. They may include the directions that we are to use exact answers. So earlier, I asked for the cosine of 30 degrees. The cosine of 30 degrees will correspond with my 30-degree ray, and it will correspond with the x value of that, and the exact answer here will be the square root of 3 over 2. Using my calculator, the square root of 3 is 1.7 and change, divided by 2 comes out to be 0.866 approximately, but here I'm looking for the exact answer. If I were then asked for the tangent of pi over 3, I would be looking at the pi over 3 ray, and for the tangent value, I'm going to look at the y value, which is the square root of 3 divided by 2, over the x value, which is 1/2. I can't leave a complex fraction there, so I'm going to write the square root of 3 divided by 2. And instead of dividing by 1/2, I'm going to multiply by 2 over 1. That's going to simplify out to be the square root of 3. Using my calculator, I would get approximately 1.7 and some change. However, the exact answer is the square root of 3. Now, both of these are in the first quadrant. So if I don't have the entire unit circle memorized and I don't have the unit circle in front of me, how do I start to figure out some of the others? Let's go into the second quadrant here. Let's evaluate the sine of 120 degrees. If I were to draw a quick sketch of this, it would be up here closer to the y-axis, which is going to be more like 60 degrees. And and 60 degrees would have a y value of the square root of 3 over 2. Being in the second quadrant, my y value is still going to be positive, so I would get a value of the square root of 3 over 2, which is the y value at 60, but also the y value at 120 degrees. If I were asked for the secant of 7 pi over 6, now we start to get into a challenging question. 7 pi over 6, is that closer to the x or y axis? 7 pi over 6 is 1/6 of pi past my negative x-axis. This would be more like my 30-degree angle, or my pi over 6. Pi over 6 would have an intersection point of the square root of 3 over 2, comma 1/2, which is going to be the same here at 7 pi over 6, except both the x and the y value will be negative. For secant, I'm looking at 1 over x. I'm looking for the reciprocal of cosine. The x value here will be negative root 3 over 2. I need to clean this answer up. I can't leave a complex fraction, so I am going to do 1 times negative 2 over root 3. However, I need to clean that up further because I can't leave an irrational number, the square root of 3, in the denominator. My final answer here would be negative 2 square root of 3 over 3. The secant of pi over 6 is negative 2 root 3 over 3, or 1 over the x value. If I wanted to evaluate the secant of 7 pi over 6 using my calculator, I would have to make sure that I was in radian mode, which I am, and I would do 1 divided by the cosine of 7 pi divided by 6. I would get negative 1.155. That's an approximate answer. Let's see if negative 2 root 3 divided by 3 is the same, and it is. So I found the secant of 7 pi over 6 using the unit circle, and I found the exact answer. I did not find the rounded decimal of negative 1.155. We're going to do one more interesting one here. We're going to evaluate the tangent of 270 degrees. The tangent will be y over x at 270 degrees. I should know this. We're going straight down on the negative y-axis. The y value here would be a negative 1, and the x value here would be 0. Therefore, this does not exist. If I were to evaluate this using my calculator, I would have to make sure that I am in degree mode, or I could stick with radian. I would just need to use 3 pi over 2 rather than 270. The tangent of 270 degrees would give me a domain error. This is going to be relevant once we start graphing the tangent curve. That'll be something to remember and consider. Moving forward, we're going to practice a lot of these evaluating using the unit circle. For right now, use the unit circle, have that in front of you, but in the future, we're going to have to start evaluating these without a given image of the unit circle. For now, I'd like you to create a table of values. On one side, we're going to have theta, and on the other side, we're going to have the sine of theta. We're going to start at 0 rads, and we're going to do every angle up to 2 pi. So we're going to go pi over 6, pi over 4, pi over 3, pi over 2. That's just the first quadrant. We're going to go all the way around until we get to 2 pi. I would like you to use radians and think about radians here. We're going to use this table of values to help graph the function f of theta equals the sine of theta. If you'd like to get into that, I would encourage you from 0 to 2 pi to graph. But for right now, definitely get those table of values and think about what that would look like as an image. Good luck.